Well, hi guys.
Whoa!
Here we are, swimming around, recording from the ocean. I hope there's no sharks out here,
I
Mr.
know.
Wood.
I'm a little concerned because I don't even have like a little snorkel. So.
Well, it's a good thing you got that regulator.
Oh, there you go. Yeah.
I'm the one that's going to struggle here if we're really deep. All right, so let's do some mass stoichiometry.
All right, sounds like fun.
First thing we're going to do is your phone's
My phone, I know.
in the ocean.
I know, it's
Okay.
a waterproof phone.
And I'm getting fogged up here.
Probably.
Let me just do a little cleaning. Okay, here we go. All right, so we started last time with mole to mole. So that's going from moles of a known substance to moles of an unknown substance.
Okay, yeah.
Okay, like we talked about a recipe, you know?
Mm-hmm.
So what we got to have is a balanced equation and a mole ratio, which comes from our...
Balanced equation.
Right, that's
Okay.
the most important thing.
Got that.
Okay, so we know that when we have that mole ratio, it's set up with unknown on the top and
the given on the bottom,
exactly.
right? Okay.
Yeah. So
That's right. I remember that from the last video.
Okay, perfect. And again, that comes from where?
The balanced equation, right?
Yes. Perfect,
Okay, perfect.
Okay. So here is our mole to mole problem that we practiced with. Okay, and we just want a quick review. We circled what we were looking for.
Yep.
And we underlined what we started with.
Yes. Yep.
So when we did mole to mole, we started with showing we had 13 moles of carbon dioxide. We set up our T-chart. Then our mole ratio came from our problem.
Yep.
Where we had 3 moles of carbon dioxide here and 4 moles of hydrogen gas there. So we set it up of what we're trying to find on the top. And
unknown over known. Right?
Exactly.
Okay, good.
And then I
Sounds
just
good.
multiply across and divide by the bottom, and
Excellent.
I cross out my moles, and I get something that looks like that.
That is perfect.
That's
yeah.
review, because of course we've already done that.
Yeah,
Okay?
excellent. Yeah, that's easy.
Right.
Easy peasy. Do it all day.
Exactly. So now we're going to do a little bit more difficult. We're going to go from mass of a substance to mass of another substance. We're really taking it one step further.
I feel like that's 2 steps.
Yes, you are very. Yes,
gross.
you are. Yes. You know,
I feel like the
subtle
under the
sort of-
water was a bad location.
I would agree, because my
I've been
mask
up
is
there.
really fogging up, and I'm struggling to see here. But you know, that's normal when I'm in the water. So, okay, so we're gonna start with what is the mass of NH3 that can be made from 100? Oh, that's a huge number. I think I altered it in the next one. 1,200 grams of.
It's a lot of hydrogen.
Yeah, so we're gonna switch that up a little bit here. We're gonna look at our balanced equation, because that's our first step, is to make sure we have a balanced equation. Okay, so I made it a little bit smaller.
That's a lot better.
Yeah. So what's the mass of NH3 that can be made from 213 grams of hydrogen? Well, our first step is to underline what we're starting with, which would be?
213 grams of hydrogen.
Beautiful.
Perfect.
So we underline it.
Yep.
What are we trying to find, Mr. Wood?
I think we're trying to find the mass of ammonia, or NH3 in this case.
Correct. So I'm going to circle that.
Perfect. Okay.
All right. Then, of course, I'm going to go ahead and write down what I know first, which
Okay.
is what we underlined, 213 grams. And I want to remember, very important at this point to make sure that we have, get a little seasick, I think, that we write down the units.
Yes.
Because now it's going to be very important.
That's right. They need to cancel out, right? At the end?
Exactly.
Okay.
Every single time. So, now I set up a T-chart. It's going to be
Whoa.
really big this time.
Whoa. That looks like a lot of work.
It does, but we can handle it. No
Okay.
problem. So, we're starting here. We're going to put up our first T. I'm going to put 2 grams of hydrogen because, of course, I need to cancel the grams. And I know that this number comes from the...
Periodic table?
Yes,
Okay.
yes. So hydrogen weighs 1, and there are 2 of them. So 2
Got you.
times 1. Yeah.
Gotcha. Okay.
And then that's the molar mass for every 1 mole of hydrogen.
1 mole of H2 weighs 2 grams. Okay.
Exactly.
I got you.
It's like 1 mole of Mr. Wood would be 150 pounds. Something like that nature. Okay?
Yeah.
Yep. So then I'm going to cancel out my grams. Oh.
Oh.
I apparently didn't cancel them out over here like I should have, but we'll get there.
Okay.
The animation must have gotten screwed up. Go figure.
What?
So now I'm left with moles of H2. Well, now that I'm in moles, I can use my magic converter, if you will, which is?
The molar ratio?
Yes.
Awesome.
And what goes on the bottom, Mr. Wood?
Well, I'm going to say my given goes on the bottom, which would be moles of hydrogen.
Yes, exactly. So my given comes from my...
Balanced equation.
And how many moles are in my balanced equation of hydrogen?
It looks like I have 3 moles of H2 in my balanced equation.
That's
All
a
right.
great
Nice.
observation. And where are we going again? What did I circle?
Eventually, we're going to get to moles of NH3, right?
Right. So that also comes from my balanced equation. According to my balanced equation, there are 2 moles in this case.
Oh, I got you. Okay, so In this step, I'm going to use my balanced equation. I'm going to make sure that my given is on the bottom.
Whoa, sure. Ah! Sorry, it was scary for a
That's
second.
not
Sorry.
cool.
Whew. Okay, sorry.
Never mind. I've lost my train of thought.
I know, I apologize.
I literally peed my wetsuit. I don't know what I'm going to do now.
Okay, well, luckily we're in plenty of water. We could get that cleared up. Okay, so once again, given on the bottom, which is what we started with, because here's hydrogen, so here's hydrogen given it. Given it. And then the unknown, or what we're trying to find, goes on the top.
Gotcha.
Okay?
Gotcha. Makes sense.
And these numbers came from?
My balanced equation.
Beautiful.
Okay.
Okay? So now we can cancel out our moles of H2 because, of course, they're gone.
Yeah,
I got a mole of H2 on top and a mole of H2 on the bottom. They cancel each other out.
So on the top, on the bottom. Yeah. Okay. Gotcha.
So now
gotcha.
I'm left with moles of NH3, which is a great start. Yes, I need NH3, but I'm looking for mass, and mass is measured in
grams.
Okay, so I got to go one more step.
All right. Let's do this.
Okay, so since I have a mole here, I know in order to cancel out a mole, it's got to be put on the
bottom.
So I'm going to use 1 mole on the bottom.
Okay.
And what do you think is going to go here on the top?
I'm going to say it's going to be how much 1 mole weighs,
Yes.
right? Which would be like, what, 17 grams?
Exactly, because I looked up that nitrogen is
14.
And then that I have 3 hydrogens, each weighing
1.
And when I add all that together,
Gotcha.
17 grams.
Perfect.
Just an easy molar mass like we started with in this unit.
And I get that off the periodic table.
Exactly.
Okay. So all these grams I'm getting off the periodic table.
Exactly, except for the one that we get from the
Except
problem.
for my given. Okay.
Okay. So now my moles of NH3 cancel, and guess what I'm left with?
Looks like I'm left with grams of NH3.
And if I go back to my problem, what are they asking for?
That's exactly what they're asking for.
Oh, perfect. So now I'm just going to do the math. Mm-hmm. Anywhere I see a vertical line, it's like a multiplication sign. So, yes,
gotcha.
Exactly. That looked like a WWF move, which I think is now WWE, but you know what I mean. Okay.
I don't.
Okay, great. So I'm going to take 213, multiply it by 1.
That's 213.
Yep, multiply that by 2.
426.
Dang, you're good. And then multiply that by 17.
Not what I know. Oh, that.
7,242. I don't know why you couldn't do that in your head. Okay, and then I'm going to throw up my divided by symbol, because that's what a horizontal line represents. Now, here's something that we haven't really had yet. We multiply everything on the bottom. So I'm going to take 2 times 3 times 1, which is
6.
6.
Now, that blank box I just leave alone?
Just leave that alone.
Perfect.
Yep, pretend that there's nothing there.
I don't put a 0 in there.
No 0. You could put a 1 if you'd like, just to suit yourself, but there's really no reason.
It's just wild and crazy.
Yep. So then I'm going to take this number, 7,242, and divide it by 6, and I get 1,207 grams of NH3.
Wow.
Yeah.
That seems pretty simple.
Yeah, it's not too hard. So I have 2 molar mass steps right here and right here. And then the only thing that's kind of new to us is the molar ratio, which comes very simply from the balance equation.
Is there another example? Can we do maybe one more?
Yeah, let's do one more.
Okay, sounds good.
Okay, remember, green circle means that comes from the balance equation because we're talking mole ratio.
Mole ratio.
Okay?
Mole ratio.
Mole ratio.
Sounds like a Mexican dancer.
Yeah, well, I like to think if I say mole ratio, it makes me Russian. Maybe. Or not. Okay.
I don't think that's how you become a Russian.
Oh, okay.
I think there's an immigration.
Oh, okay. I'll work on that. So we got a new problem here. Magnesium plus sodium fluoride, and we're going to make magnesium fluoride and sodium. Okay?
Yeah, why not?
So if you start with 5.5 grams of NaF, how many grams of MgF2 will be produced?
Suspense.
Yes, I know. It was like, woo. So I always want to underline what I'm starting with, which would be?
5.5 grams of NaF.
Beautiful. And I'm going to circle what I'm looking for, which is
grams of MgF2.
Beautiful.
That one's tricky because you flipped it around.
I know, and we got to get used to that.
Yeah. Okay.
So we got to be ready for anything, really.
I am prepared for anything.
Especially those sharks if they come back.
I'm like a Boy Scout, yes.
Yes. So I write down what I know from the problem.
Yes, 5.5 grams.
Right. Okay. Now, because I have grams, I know that I have to get rid of grams. So tee it up.
Oh, I hate that. Look at that long T chart.
Right. So I tee it up, and I know that I have to put grams of
NaF
on the bottom, which is me going to the periodic table and looking up grams of nitrogen plus fluorine.
42.
42.
That is 41.
Yeah, 23 plus 19.
Yeah, 23.
Yeah. And then, of course, that's for every 1 mole.
Yes. Gotcha.
Okay.
Gotcha. That's how much a mole weighs.
Exactly. My grams cancel. I tee up my chart again. Now I'm left with moles. Now that I'm in moles, here's where I could use that really new fancy fangled contraption. I'm really fogging.
I can tell.
I need to do like a little spit and wipe, but I won't do that on camera.
I appreciate that.
You're welcome. So I'm going to do my fancy new thing that we learned, which is called our...
Molar ratio.
Yes,
Mole
and
ratio.
then what goes on the bottom again?
On the bottom mole ratio goes my given.
Okay.
Given's always on the bottom.
Given is always on the bottom, and that's what I have right here is the given, because that's what I started with.
Exactly.
That's what they
The
given
number.
me.
Oh!
See how that works?
Mole ratio gave it to you.
Yep, so I go up here to my balance equation, and how many moles of NaF do I have according to my balance equation?
It looks like I've got 2, right? Because there's a 2 in front of NaF.
Yep.
Okay.
And where am I trying to go again?
Looks like I'm trying to go to MgF2.
So then I go over here and see how many moles of MgF2 do I have?
It's 1, right? Because there's no number in front.
Exactly.
So it's 1? Okay.
So my moles of NaF are going to cancel. I'm left with moles of MgF2. So I'm on a great start because I'm trying to get to MgF2, but I'm in moles. I need to get to grams.
Yeah. So we're mostly there, though. We're
halfway there.
We're living on a prayer.
Yep.
We're
So we're going to get rid of our MgF2 by using what?
Sorry.
Yeah, you're really distracted.
We're going to put moles of MgF2 on the bottom, right?
Yes.
Good.
And we're going to do 1 because we only want to know what 1 mole is.
Yeah.
And what goes on top?
I'm going to say what we're looking for, which would be grams of MgF2.
Exactly. The grams of MgF2, and I found that from the periodic table. But that looks a little low.
I feel like that's going to be because F is 19 by itself.
Exactly, and there's 2 of them. I'm not really sure what happened here. So we're going to just go with it.
We're going to pretend it's that?
Yeah, don't write that down. This number should be, magnesium's 24.
Yeah, something like that.
Plus 19 and 19, which is...
38.
38 and 24, so
62.
62-ish. So change that right here to 62. Okay? 62 goes right there.
It's okay. You're fogging up. You weren't paying attention.
Exactly.
The shark scared you more than...
It's true.
You're very stoic. I
Yeah.
appreciate
Man,
it.
I thought I would have had this one down.
You're very stoic geometry.
Very
You
funny.
like that?
So now I'm going to multiply across the top, and I'm going to get 150, but that's, of course, because of this number is screwed up.
Mm-hmm.
But for the sake of knowing what we're doing, we're just multiplying 5.5 times 1 times 1 times...
27.3.
Yes. And then, here's where it's going to get a little different. We're going to put our divided by sign again. And I got 42 times 2 times 1.
Which is 84.
So now I'm going to divide those. I'm going to get 1.8 grams of MgF2. If my molar mass was correct, that'd be a great answer. However,
That would be.
I was slightly flawed.
That's okay.
But,
That's okay.
you know, sometimes things happen, and I get it. But at least, because I showed my work, you could see where I went wrong.
You know, looking at you, I can't believe that anyone would think that you would be flawed. You seem so with it and together.
What a guy. I'm going to throw a quick circle, too, around our mole ratio, because I want to remember where does that come from.
My balanced equation.
You got it. Okay? So, a couple of reminders. You got to write what you know first. And each problem should always have a mole ratio, which comes from...
My balanced equation.
Exactly. All right, kids. We're taking the plunge and getting out of here.